Automatic. Addison.
In this tutorial, we will explore templates and macros in C++. Let's explore how to use macros in C++ and their application in robotics projects. Macros are preprocessor directives that allow you to define reusable pieces of code processed before compilation. All right, so now we have Visual Studio Code open, and let's create a new file called basicmacro.cpp. All right, and let's type the following into the code editor. #include iostream. And let's define a constant macro called pi. You're all familiar with pi, 3.1415.92654. And let's define a function-like macro, #define area, circle, radius, and let's go over here, pi times radius. Let's actually put it into parentheses here, times radius. Int main double radius equal 5.0. Double area equals area circle radius. Stood see out the area of a circle with radius. Okay, and over here, we're going to actually drop in radius here and say is area. Okay. And then we need to end the line, stood, end L. And then return 0. Then save. Okay, so what are we doing in this code? In this code, we define two macros. Pi, a constant macro that defines the value of pi, and then area circle is a function-like macro that calculates the area of a circle given its radius. In the main function, we use the area circle macro to calculate the area of a circle with the radius 5.0 and store the result in the area variable. We then print the calculated area using stood cout. Now we run the code and we see the area of a circle with radius 5 is 78.5398. So it's important to note that macros should be used sparingly and with caution, as it can sometimes lead to unexpected behavior if not used carefully. In modern C++, const variables, inline functions, or templates are often preferred over macros when possible. But now you've been exposed to macros. So if you ever encounter this in someone else's code, you know what it is. Let's explore template functions in C++, which allow us to write generic functions that can work with different types of data. This is particularly useful in robotics when dealing with various sensor data types or mathematical operations. So let's create a new C++ file and name it template functions example.cpp. And let's type the following into the code editor. Template, type name, T, and let's do T, find max, T A, T B, And let's do return A greater than B. And then the question mark, and then A:B. And down here, we'll do int main for our main function. And let's do std cout max of 10 and 20 is, okay, and over here we need to use the find max. Int, and then 10, comma 20. Std end L. All right, and then on the next line, we need to do, let's just actually copy paste to make our lives easier. And let's do 5.5 and 2.1. And over here, we're going to do double. And let's do 5.5 and then 2.1. And we'll do return 0. Okay, so in this code, we define a template function, find max, that takes two parameters of the same type and returns the greater of the two. The function uses the ternary operator to compare the two values. We then test this function with integers and doubles to show its versatility. Now let's run the code. And here you can see the output here. The output should display max of 10 and 20 is 20, and the max of 5.5 and 2.1 is 5.5. So this demonstrates how the template function adapts to different data types. Let's explore template classes in C++, which allow us to create generic classes that can work with different data types. This is particularly useful for creating reusable data structures and robotics applications. Create a new C++ file and name it templateclass.cpp. Templateclass.cpp. Okay, and type the following into the code editor, #include iostream. Okay, template, type name T, class point, private, tx, ty. Public, point, tx, comma, ty, x, x, y, y. Let's do t to get x, const, and then we'll do return x. T get y, const, return y. Do void print point const. We'll do std cout. And let's put in x. And we'll do y. And we need to end the line, std end line. All right, and now we need to close it out with the curly braces. We got that. Let's take a look, see if it's all good. Semicolon. Now let's do our main function. Point int point 5 comma 10 point double point 3.14 2.71. Let's do stood cout integer point, and we'll do int point dot print point, and we'll do stood cout double point, and do double point dot print point, and return 0. Okay, what are we doing on all this? As always, I will explain. So in this code, we define a template class called point that represents a point in 2D space. The class has two private member variables, x and y of type t. The type name keyword is used to specify that t is a type parameter. The point class has a constructor that takes x and y values and initializes the member variables. It also provides getter functions, get x and get y, to access the values of x and y respectively. The print point function is a member function that prints the point in the format x comma y, like you commonly see when you're typing out a coordinate or reading a coordinate. And now below this, in the main function, we create two instances of the point class, int point with integer values and double point with double values. We use the print point function to print the points and verify that the template class works correctly with different data types. Now let's run the code. Pretty cool, huh? So the output displays the points created with integer and double values. So template classes provide flexibility and help reduce code duplication, making the code more maintainable and efficient. You can see how C++ is a Swiss Army knife. Many different functions. Thank you for watching, and I'll see you in the next tutorial. Keep building.